So I want to take a little bit of time here to show you how the periodic table can be used for discovering electron configurations. There are lots and lots of patterns in the periodic table. It's not arranged in any random way whatsoever. So let's look at some electron configuration patterns. I'm going to start by looking at hydrogen, and it has an electron configuration of 1s1. And then if I look at lithium, it's going to have an electron configuration of 1s2, 2s1. And then if I look at sodium, 1s2, 2s2, 2p6, 3s1. Now you immediately notice, I hope, that they all end in the same way. They end in s1. And you might be able to predict then what potassium's electron configuration would end with. If you said that potassium's electron configuration should end with 4s1, you'd be right. Now let's look at some of the other patterns there. Hydrogen is in the first period, and it ends with 1s1. Lithium is in the second period, and it ends in 2s1. Sodium is in the third period, and it ends in 3s1. Potassium is in the fourth period, and it ends in 4s1. Now, maybe you've heard of the different blocks of the periodic table. In your reading, you should have come across that. And everything that I'm highlighting there in blue is known as the S block. So let's look a little bit further here. And let's look at some of the other atoms in the S block. So if we look at beryllium, beryllium has an electron configuration of 1s2, 2s2. And then if we go down one row, we're at magnesium, 1s2, 2s2, 2p6, 3s2. And hopefully you notice right away the s2 ending. And so the first group in the S block is S1, right? All the electron configurations end in S1. And in the second group, all the electron configurations end in S2. Well, let's keep going. Let me erase some of this stuff. And we'll look at some of the elements over on the other side of the periodic table. Let me see, let me highlight this. All of this stuff here in green represents the p block. Now, if you remember p orbitals or p sublevels, there are 3 orbitals in a p sublevel, and it can hold 6 electrons. And so you shouldn't be surprised then that there are 6 columns in the p block. So p1, p2, p3, p4, p5, and p6. So if we write the electron configuration for, well, let's say carbon, 1s2, 2s2, 2p2. Now, carbon is in the second period, and it's in the second column here in the p block. And so the 2p2, I know that carbon's electron configuration is going to end with 2p2 because of that. In the same way, if I were to write the electron configuration for fluorine, I know that it will end in 2p5 because it is in the second row, right? It's in the second row and the 5th column of the p block. So then I know it's 1s2, 2s2, 2p5 for the electron configuration for fluorine. Now the center of the periodic table, where the transition metals are, this is known as the D block. The D block is a little bit different, and I'll get into that in another video. And then let me give you one more down here at the bottom. Perhaps you can guess what that's going to be. That is the F block. So in each of these blocks, whatever block the atom is in, that's the block that is going to be filling up with electrons. All of the previous sublevels have been filled. But if it's in the P block, then we're adding electrons to that p sublevel. That p sublevel will be partially filled until you get all the way to group 18, where the elements will have 6 electrons in the p sublevel. Right, except for helium, of course, because it only has 2 electrons, so its electron configuration is 1s2. But neon would end in 2p6. Argon will end, its last sublevel will be 3p, and so it will be 3p6. Krypton will be 4p6, xenon will be 5p6, and so on.